Okay, imagine this. You're sitting in Lagos, or, maybe London or Jakarta. You've just finished building a brand new app, and it runs absolutely perfectly on your laptop. You type localhost into your browser, and boom, there it is, the whole shebang. But here's the real question. How exactly does that specific app, sitting right there on your local hard drive, reach someone who just opened it on their phone in Germany in under a literal second?
Throughout this explainer, we are taking an epic journey. We're going to trace one single piece of code from a lonely laptop all the way to a massive data center and ultimately out to millions of users globally. We're unpacking that invisible, beautifully engineered infrastructure that is firing across the world right this second, just to load up a screen for you. All right, let's dive right into Layer 1, APIs, or as I like to call them, the digital waiters. Because before your app goes global, it absolutely has to know how to talk to the rest of the digital world. Think of it like a restaurant. Your app is the customer sitting at the table. The database, the place holding all the actual information, is the kitchen. The API, that's your waiter. Your app asks the API for, say, the weather forecast. The API runs back to the kitchen, grabs that data, and brings it right back to you. You get exactly what you ordered, and you never even had to step foot in the kitchen. To put that into perspective, let's break down what a real API request looks like in plain English. Say an app asks a weather API for the conditions in Lagos. It sends a simple GET request, the API checks its database, and shoots back a text format called JSON, confirming, yep, it's 32 degrees and sunny. It's clean, it's simple, and honestly, it's the universal language that literally every programming language understands. And this digital waiter basically uses 4 main methods to handle all your requests. GET is for retrieving data, like loading this explainer right now. POST sends brand new data, like when you hit a like button or post a comment. Then you have PUT or patch to update existing data, like editing that comment. And finally, delete, which, removes it entirely. Whether an app is a tiny side project or a massively complex system, these 4 actions are the fundamental building blocks of the web. Moving on to Layer 2, servers and Docker containers. So how does your code actually escape your laptop and get to a real data center? Because right now, nobody outside your house can see it. Well, there's basically a 9-step assembly line for this. You write the code, you push it to a version control system like GitHub, and that triggers an automated build process. Your app gets packaged up, pushed to the cloud, and deployed onto a massive server, maybe sitting in an AWS region somewhere in Ireland. You point a domain name at it, and suddenly, you're alive to the world. But the absolute hero of this entire process is Docker. I mean, Docker changed tech forever because it killed that ultimate developer nightmare of, well, it worked on my machine. You see, a Docker container is literally a digital shipping container. It neatly packs your exact code and all its dependencies together. So whether it's running on your laptop in Lagos or a massive server in Frankfurt, it behaves identically. Zero surprises. A total game changer. Okay, Layer 3, DNS, the Internet's phone book. So your code is hosted on a server, right? And that server has an IP address, a super clunky string of numbers like 54.72.145.18. But humans don't memorize random IP addresses, we type in domain names. This is exactly where DNS steps in. When someone types myapp.com, their device asks a DNS resolver to look it up. It checks its records, like the A record, and seamlessly translates that human-friendly domain into your server's actual IP address in milliseconds. It completely bridges the human-readable web and the machine-readable web. Next up, Layer 4, CDNs and global scaling. All right, so your app is live, users are flooding in, but now we hit a literal wall of physics, the finite speed of light in fiber optic cables. That physical distance means data traveling from a user in Lagos all the way to your server in Ireland and back takes about 300 milliseconds. Now, I know that sounds fast, but in the digital world, that's an eternity. For heavy images or code, your users are going to feel that lag. They'll be waiting. And you know how it is. Waiting users just leave. The clever solution here is a content delivery network, or CDN. By caching copies of your heavy static files, like images, on edge servers all around the world, you basically cheat geography. So instead of traveling all the way to Ireland, a user in Lagos downloads the images from a node sitting right down the street in Lagos. Latency drops from 300 to a blazing fast 10 milliseconds. And suddenly, your app feels instantaneous. But what about the dynamic data? When your app goes viral, a single server will just melt under the pressure. This is where a load balancer steps in as the ultimate traffic cop.
Cloud platforms spin up new servers automatically, and the load balancer smoothly distributes incoming users across all of them using routing methods like round robin. And the best part, once the viral surge is over, it shuts those extra servers down to save you money. Layer 5. Multi-region deployments. Now, let's look at what happens when you need to run copies of your app in multiple data centers around the world simultaneously. Copying code is easy. Copying databases is an absolute nightmare. Keeping data synced across continents forces developers to make a choice. You can use active-passive, which means one main region writes the data, while the others just read it. Or you go active-active, letting every single region read and write at the same time, syncing in near real time. It requires some truly wild engineering, but it means a user in Tokyo gets the exact same database speed as a user in New York. Layer 6. Zero downtime app updates. So your app is a global giant now. But how do massive companies like Netflix or WhatsApp push out entirely new updates to millions of users without ever showing a scheduled maintenance screen? The first trick is blue-green deployment. You basically run two identical environments. The active blue one handles your live users. Meanwhile, you silently deploy the update to the hidden green one. Once you're 100% sure it works, you literally just flip a switch on the load balancer. Traffic instantly routes to green. And hey, if it crashes, you just flip the switch back. Zero downtime. Then you've got rolling deployments. This is where you replace your servers batch by batch. You take server 1 offline, update it, and put it back. Then you move to server 2. The app stays alive the entire time, continuously serving users, and nobody notices a single thing. And for the absolute ultimate safety net, we have canary deployments, named after those birds coal miners used to carry down to detect danger. Here, you send just a tiny fraction, maybe 1% of your live traffic to the new version. You watch them closely. If the code breaks, well, only 1% are affected. If it's safe, you dial it up to 10%, then 50%, and eventually a full rollout. This is exactly how massive companies like Meta push updates safely. And finally, Layer 7, the full stack journey. Let's bring every single thing we've just covered together into one rapid, complete story. You push your code locally. Docker perfectly packs it up. It deploys to an auto-scaling cloud cluster. A user types in your domain, and DNS translates it in milliseconds. The CDN serves up the heavy visuals instantly from a server down the street, while the load balancer routes their dynamic data smoothly to your multi-region database, and it's all updated flawlessly with a canary deployment so a connection never, ever drops. So the next time you tap an app on your phone, just pause for a second. Think about that massive, invisible, beautifully engineered symphony of APIs, DNS lookups, and edge servers firing across continents at the literal speed of light. All of it working together in a matter of milliseconds just to show you that one screen. It is modern magic. So, what does this all mean for the future of how we build the web? Keep exploring, because the infrastructure running our digital world is only getting smarter.